In this video, we will learn about line plot. Let's understand this. Whatever definition of line plot you get over the web, I split them in this way. It shows the relation between two variables, majorly used in time series analysis. This is majorly used in time series analysis. And if you combine these two, you get it concludes in we use the line plot to showcase how the value of variable changes over the time. For example, here if you see on x-axis, that means at the lower side we have plotted the year for an outlet, and over here at y-axis we have plotted sales of that outlet. And now this line shows you how the sales of that particular mart changes over the time. When you create first plot in your Seaborn, then you get this kind of line plot where this center line, by default it represents the mean of this value. So for example, in 98 the mean of sales was 2500 around. Now you must be wondering, what is this shaded area? So this shaded area is nothing but the 95% bootstrapped confidence interval, plus minus 95% bootstrap confidence interval. Now if you are surprised that, or maybe if it sounds like alien language, what bootstrap confidence interval is, don't worry, we will be covering that in detail in our statistical video series. But for now, if you are interested in learning that, though it is not going to be required, but if you are interested in learning that, I can suggest you one video on YouTube which explains it very well. Let me show it to you. Here the channel name is StatQuest, and here this video, I'll be providing the link for this video in description section. Don't forget to check that out. This video explains bootstrapping in a very nice way, so you can just give it a watch to understand. Hello everyone, welcome to the channel, and to understand the concept very clearly, please watch the video till the end. Once you are done with watching the video, do not forget to like, comment, subscribe and hit the bell icon. By default, line plot accepts all these arguments as per official website of Seaborn. Out of this, we will be covering or discussing all those arguments which are most frequently used and are important. Here I am at Python IDE, which is of course Jupyter Notebook, and here I have imported all the required libraries. You can do the same. And here I am using this data frame. I'll be uploading this data frame in Excel on GitHub. You can download it from there. And I'm creating one additional variable tier over here. You don't need to worry about. I'll be uploading the final data. So you can just simply download that and import that, and you can use that. Now let's start with creating a basic line plot. Don't get confused and don't focus on this example as of now. I'll show you why I have written that. For now, the first problem statement says create a basic line plot and try different estimators. I'll explain you what all these things are. So here I'm just going to use the mart data frame. Here is a view of mart data frame. Out of this, we will be using mostly sales data. Here it is, and then the outlet year, and we will also use this outlet size and tier as well. Let me take it forward, and here you just need to say SNS, then line plot, and in that, first as usual you need to provide the data frame name, which is mart, and on x-axis I want to plot outlet year, and on y-axis I want to plot sales. And let's run this. Wow, we first got the error. The spelling of year is not correct. Okay, there is something more wrong. Let's see what is wrong. Again, the spelling must be with capital Y. Now here you're gonna get the first line plot. For now, don't get confused with this shaded area. For now, I am just going to hide it, and we will be discussing that in next step. So for now, I will just say confidence interval is none, and that's gone. So if you see over here, this is showing you by default, like I said, this line represents the mean of this sales, right? By default it is showing mean of sale. So if you see, somewhere in 95 the mean was somewhere 2200, but at the same time it gives you the facility to change the estimator. That means instead of mean you can also show sum, right? Let me just show that. So here if you notice, previously it was the measurement on this y-axis was different, now it is different. So now this is showing the total sum done in the year, maybe in 96, that could be somewhere here around. In 96, how much was the total sales? Instead of mean, it is showing you the total sales. At the same time, if you are interested, you can show the individual value points, each of the individual value point across the time. For that, all that you need to do is just say none, estimator equals to none. Now this is showing each of the data point by the year. So for example, in 1990 the total sales amount was somewhere 5000. Similarly, it's somewhere in 1999 it was less than 0, something like that. So this is how it is showing the individual data point. If you want more clarity around this, let me show it you with an example. So here I'm using none. So if you notice over here, we have height, this we will be plotting on y-axis, and age at x-axis. We are going to plot this, right? So here we will be showing the individual points. So what will happen in this chart? Let's see that. So if you see, the height is 5, and for two different ages the height is 5 feet. So what are those two different? One is for 22 years. Let me show it to you first in the example. 22 years, 42 years and 35 years. For all these three ages, you have the height is 5 feet. So here, as you can see over here, 5 feet. Then over here somewhere this accounts for here 35, right? And then this one 42. At these 3 points the height is 5 feet. So that means it is showing the individual one. Now let me just comment this again, and here what I'm going to do is I'll just uncomment this, and here I'll run. Again we have age at x-axis and height at y-axis now, but the value is slightly different. This time we have some common values at x-axis. So for example, if you see 25 is repeated 3 times, and for all these 25 years aged people we have different height. Let's see how is that representing. So this time it is showing sum. So if you see here we have 25, and for the people who are aged 25, the sum of height is, you can take a sum. For 25 here it is 6.5, and then 4 it becomes 10.5, and then this is 10.5 and 6, somewhere 16.5, which you see that is over here 16.5, right? So this is how you can use different estimators in this default line plot. Now moving forward, as I showed you in the initial, it was showing shaded area, right, where I just said confidence interval equals to none. Now let me remove this and let me run this again. So you have this shaded area. This shaded area shows the confidence interval which I explained in the beginning, and this center point explained the mean which we just saw. Now by default it is showing the confidence interval, but if you want you can change it. For example, this line is showing you mean, and if you are interested in seeing the standard deviation of that mean, then you can set that in this confidence interval. All that you need to do is say st, and then you have the standard deviation of this mean. So for 1990 the mean value is somewhere 1900, and the standard deviation is ranging between somewhere 2900 to somewhere 500. All right, this is the range in which this is the spread of the data for 1990. All right, so here you saw that by default it shows the bootstrapped confidence interval, and you can change that to standard deviation. You can also do it none, which we just saw in the previous example. Other than this, if you want, you can change the by default it shows 95%. If you want, you can change that to, let's say, 20%, for example. So here you say that 20% is too low, right? So by default it is 95%. So let it be. I'll remove this because by default it is not required. Now by default it shows you the confidence interval, which is based on bootstrap. Now you can change the number of bootstrap as well. So by default number of bootstrapped is 1000. You can change it to, let's say, 20 number of bootstrapped. So it has no effect because still these all samples have the mean which is near to the actual mean, But let's say if I say 2, that is very low, right? So that is changing it. By default it is 1000, but you can change it to whatever you want. Moving forward here, now we will see some styling of the line plot. Let me just copy this from top. For the sake of simplicity, what I'll do is I'll keep confidence interval as none, but you can keep as default if you like that. If you wish to see the confidence interval, you can keep that. Usually it is advisable if you are going to have multiple lines, don't use confidence interval. If you're going to just have one line, then of course you can use. Right now this is showing you the sales over the time, right? What if I want to see this categorized by the outlet size? What is the impact that outlet size have on sales? If you want to observe that, for that you just need to say hue, and in that you can supply that variable outlet size. And let's see, now you have 3 lines for each of the outlet. This blue one represents to the small outlet, orange is medium, and so on, right? Like you can see in 2005 the medium outlet had drastically low sale, and the high outlet size had significantly high sales, right? So if you see, by the time, almost all the time, the high outlet size have better sales. But if you see the small outlet size, that is doing fantastic in somewhere 2007, maybe 2007, it is doing excellent over here. Now this was the just categorization. What if you want to change the color of this each of the line? For that you can use palette. There are 2 ways of using the palette. Number 1, which I always explain you in all of the videos, just pass a blank value, go over here and choose any acceptable palette from here, and you can just put it right here, hit Ctrl+Enter, and now you have it. The other way is, if you know what all are the values you have in this categorical variable, then you can pass a list of colors, that many list that with that many elements, right? For example, here I know 3 elements are there, right? 3 values are there in outlet size. So what I'll do is I'll just say red, green, and blue. These 3 color I'll just pass, and bingo, you're gonna have all these 3 lines in 3 different colors. So this is how you can play around the hue and its options, in its other options, right? Now moving forward, in the next example we're gonna see, this was the hue. Now what if we want to have some pointers on that, right? Wherever we have these values here, against that we want to have some pointers, or maybe we want to have different kind of lines. What is it that we can do? Let me show it to you very quickly. Again, what I'll do is I'll just copy this syntax from the top, and this time I'm just going to remove this simple, and then we can use style parameter or argument, whatever you feel, you can say it, style argument, and in that I'll use the same variable which is outlet size, and I'm gonna run this. If you see over here, you have 3 different line for 3 different outlet size. Now, like I said, if you want, you can use the pointers as well. For that, you're gonna say markers equals to true. You have this true markers. Now, for example, if you think that marker is enough on the line because you have 3 different markers. For small outlet size, you have rounded, for medium you have a squared marker, and for high you have something, okay, for medium you have crossed marker, and for high you have squared marker. So if you want to have a regular line instead of dashed one, so what you can say is dash is equals to false. By default it is true. Now you can just say false. So here you're gonna have plain line, but on top of that markers will be available, which solves your problem. So this is how you can use the style parameter and different markers or dashes, whatever you like, right? Now next option, in the next styling parameter, what we're gonna say is there is one more styling parameter which is size. In that you would be able to define, you will get different thickness of each of the line for which is representing different outlet size. Let's see that size, and in that you again need to say outlet size, and let's run this. Here we go. So here you have the 3 different thickness of each of the line representing to each of the outlet size. The thickest one is small and the thinnest one is high. Medium is of course medium, right? If you want, you can give the range of this sizes as well, right? Let me show you. So in that, let's say I want to see it from 0.5 to let's say 10, and let's run this. Ooh. So here you can see 10 is too huge, I can say 5, 0.5 to 5. So 0.5 is for high and then 5 is for small, right? Thickest one is the small outlet. Now let's see the other example. What is it that it says here? It is asking, so we just saw 3 different approaches of styling the line plot. Now other than this, if you want, you can combine them all together. That's the best feature. So let's say here we have hue, all right, and in that we are passing outlet size. Now if you want, you can also combine this with the style, because if with you will get different colors, right? And what if you want to have different style of lines as well? So you can combine these two. There is something wrong. Let me see what is it. Okay, so S should be smaller one. Now if you see, you have different colors for different lines, right? So that is happening. Color is because of hue and different line style is because of style, right? And if you want, you can include the markers as well over here. Markers equals to true. Now you're gonna have different markers as well. All right, so if you see the orange dashed line, that represents to medium, solid blue line with the rounded marker, that represents to small outlet, and so on. So this is how we saw how we can combine style and hue as well. Let's try to combine for simplicity. Okay, so here we just saw that we are using same variable, but if you want, you can use different variable as well. Let me just try this tier. All right, so now you would have 9 lines because it makes there are three items in each of these two variables, so 3 into 3, it's going to be 9. So altogether you would have 9 lines. For example, if you observe the orange one, the first one you have dashed orange line, then you have solid orange line, and then one you have dotted orange line. So the dashed one represents to the dashed one is representing to tier 1 medium outlet size, right? And this is how you can relate to the different outlet size and the tier, right? In what tier that outlet is available. So in the it is always advisable to keep the same variable in both of these two styling parameters. That makes it simple to understand, right? Now here we just saw the combination of a style and hue. Let's try combining size with this, right? Let me just do this, and here I will just use size, and with that again I'm going to use outlet size in the same variable, right? So if you see, these two are combined, thickness are changing because of size and the color is changing because of hue, right? If in the same way, if you want, you can use different variable over here as well, and you would have again 9 different lines for the different combination. So this is it. This is how you can use the line plots in your visualization, and you can do the exploratory. Thank you very much for watching the video. I just hope that you liked it. Just in case of any doubt, do not hesitate to put that into the comment section. We also welcome the feedbacks from you so that we could make our next videos much better and easy to understand for you. Once again, thanks. Wish you very good luck.